Okay, first lesson of a new chapter, and it opens up talking about special lines. And some of these lines aren't that special. We studied them last chapter, so if a lot of this lesson seems like a review, great. It's a great starting lesson for the chapter. There are a couple of new lines in here, although I'll try and explain them in such a way that they won't seem all that weird. So we start off with this horizontal line here, which we got a little flavor for last chapter. We saw a little bit about horizontal lines, but not too much. So we really want to talk about horizontal lines. And by horizontal lines, I'm just going to put some arrows at the end of this line so you can really see which line I'm talking about there. Is that horizontal line right along there, all at y value 7 there. So if we look at that using the perspective of last chapter we would have been looking for the y-intercept and the slope. So to look at the y-intercept of this line, that's not weird at all. There's the y-intercept right there. I'll put a dot right there. Y-intercept 7. That's not weird. Now, what's the line slope? Now, that might not be easy to answer because the answer that might come to your brain is, oh, well, there's no slope. And what we really mean by that is we're asking the question, how much is this line going up by? What's its rate? What's it rising by? And this line isn't rising at all. It's not going up at all, so its slope is 0. And so far, maybe you're unimpressed that this line isn't that special. If we were to fill these numbers into the equations that we used last chapter, which is y equals mx plus b, so in last chapter we would have said this was y equals mx plus b, and we would have had to figure out what this slope was, or the rate, and here it's 0, and then the y-intercept, which was 7. And last chapter we would have just gone ahead and called this y equals 0x plus 7 if we had encountered it. We were mostly protected from it last chapter. Now, notice though that 0 times x, no matter what the x value is, you're always going to get 0. So that first term is always 0. And then so it's 0 plus 7. This line, and what's weird about it and what's special about it is it doesn't look like y equals mx plus b exactly once you find the equation. It's just y equals 7. If you want, it's just y equals b. So that's the first big thing of this lesson. Horizontal lines have an equation that looks like just y equals 7 or y equals 10 or whatever number you're talking about. Y equals the y-intercept basically because they have 0 slope. So to practice that, we look at a couple examples. And again, this is missing the arrows in the end. What would the equation of this one be? It's a horizontal line. So it has equation y equals some number. Not y equals mx plus b because the mx part has disappeared. We just need y equals the number. What's the number? What's the y-intercept here? -6. This one here, again, a horizontal line. That's our trigger, is that if we see a horizontal line, we know it's going to be y equals mx plus b, but the mx is going to disappear because the slope is 0. And so we just get a line that's y equals the y-intercept, and here is the y-intercept is 15. I mean, there's a bigger idea here, is that the equation is just telling you exactly what's going on. It's saying the y value is always 15. Look for a line where every single y value is 15. So to do that in reverse, it says draw the graph of the following line, y equals -9. Well, we just need a horizontal line that goes across at the value -9. And if you want y equals 13, you just need a horizontal line across at y equals 13. Hopefully with your ruler you can draw a little straighter than I can on the screen here. Now, maybe at that point in the lesson you're unimpressed. You're like, you said this was going to be special lines. That didn't seem that difficult at all, and it seemed to be a lot of what we were doing before. And the answer is that's very true. These lines are just slightly different than the other ones. Maybe special is too good of a word for them. There is one coming up that's a little bit weird, but this one, you're right. Horizontal lines, pretty straightforward stuff. Next, lines through the origin. Well, if you're unimpressed by the last part, you're going to be really unimpressed by this part because we totally studied this. I just want to make one little point about it. So here's a line through the origin. Last chapter, we would have called this direct variation. And what's the y-intercept here? Well, if it goes through the origin, it has y-intercept 0. Now, this one does have a slope here. I'm going to quickly find it. It has rise 2 and run 3, so the slope here is 2/3. And so last chapter, we would have gone ahead and called this y equals 2/3 x plus 0. But adding 0 really doesn't do anything. So this line really should be called y equals 2/3 x. So instead of, okay, so we started saying lines have the equation y equals mx plus b. Then we did an example where we go, well, if the m's 0, the equation won't be y equals mx plus b. It'll just be y equals b. Now, down to here. If the y-intercept is 0, then we won't have a y equals mx plus b equation. We'll just have a y equals mx equation. So I don't think that that's completely weird, and we definitely ran into that last chapter. So to find equations of lines through the origin, you find the slope. In this case, I find it as 3/5, and you write down the equation y equals 3/5 x, and I don't have to go plus b because the plus b is plus 0 because it's going right through the origin. This one here, quickly do the slope here, down 2/3, so y equals negative 2/3x. Again, I don't need a plus b on there because the b is 0. Okay, so this one. Draw the graph of the following lines. It says y equals 4x, but there's no y-intercept indicated there, so that means the y-intercept is 0. Slope is 4, so it's going up by 4s. And I'll try and draw this as straight as I can on the screen. There you go. And then y equals negative 4/3 x. We start at 0, but watch this scale here. Down 4/3, down 4/3. So just be a little careful looking at the scale to make sure you're going the right amounts every time. I don't have a ruler, so I'm going to have to, each of these, I'm going to have to actually get all the points down here so that I can draw a nice straight line. And going this way, it was down 4 for every over 3, so something like this. And then this. And then this. And then this. And then this. And that should give me all the points I need. I mean, you don't need all those points when you're drawing it. You've got a ruler that you can use. And I've tried the straight line tool in Word, and it doesn't work very well, so I'll just draw the points and get a nice line through there. What's the point of all this? No joke. The point is, let's just make sure that's through there like that. The point is, if there's no y-intercept indicated, we mean y-intercept of 0. Okay, so maybe you're unimpressed, but this one you should take a close look at. Vertical lines is the one kind of line that can mess people up, especially after doing a whole chapter of y equals mx plus b. Vertical lines can cause you a little bit of problems. So I'm going to show this vertical lines just a slightly different way than the other lines because the equation is slightly different than what we've seen before. And I'm going to say, it asks for draw 5 points on the line, so I'm just going to put 5 points on here. 1, 2, 3, 4, 5 different points, and it says list the coordinates of the 5 points. So my uppermost one was 3, 7. Then I got a 3, 4. Then the one right on the axis there is 3, 0. And then it's 3, negative 2. And then it's 3, negative 9. Those are the 5 points on my line. Now I want you to notice this line doesn't have a y-intercept, so there's no way to use a y-intercept. I don't mean doesn't have one like we meant up here. This one, you might have said it doesn't have a y-intercept. Yeah, it does. These lines up here had y-intercepts. The y-intercepts just happened to be 0. That's all. It went through the y-axis at value 0. This line's completely different. It doesn't have a y-intercept at all. So y equals mx plus b is out. So we might have told a little lie last chapter. We might have said something like, the equations of lines always look like y equals mx plus b. And they did, all of those lines we were looking at, but there should have been a comma there. The equations of lines always look like y equals mx plus b unless they're vertical. And vertical lines look completely different. It's not too hard though. Take a look. What do all the points have in common? Every single point here has x value of 3. And that indicates or points us towards what the equation of lines that are vertical will be. The equation will be completely different than what we've seen before. We just have to write x equals 3. And what we're saying is all the points on this line will have x value 3. Maybe you were prepared for that already. If horizontal lines look like something like y equals negative 6 or y equals 15, then vertical lines should be x equals whatever, and in this case, x equals 3. Like this example here. A vertical line going through negative 5, equation x equals negative 5. A vertical line going through x equals 9, x equals 9. And then it says draw the graph of the line x equals 13. When I see x equals 13, that's got to trigger me to going, oh, X equals, not Y equals like the other lines I've seen. X equals, meaning it's a vertical line. And where's that vertical line? It's at the X value 13 right there. Okay. So just a quick review. After a full chapter of graphing lines, we thought that y equals mx plus b was the end of the story. And it mostly is. These three special lines are three special cases that you'll see that are slightly different. I would definitely make up a little study note for yourself of the three different lines that you got here, because those special lines are going to come up. We're going to review it a couple times this chapter, but those special lines aren't going to go away. All right. Have a great